right, so in this example, it's asking us to evaluate this, and because this is a sort of basic level integration by substitution question, they're going to help us out by giving us the value of u. So they say, hey, u is this, and where do you see that? Right here. So we're going to go from there, and we're going to say, let's substitute, okay? And you might want to write the integral like this, 1 over x squared plus 2x minus 6 times x plus 1 dx. Okay, you might want to write it like that because this right here, u, is 1 over u. And we do know the integral of 1 over u, right? So let's think about this, though. We know what we have to do over here is we have to take du, right? And so the derivative of u is 2x plus 2 dx. Okay? 2x plus 2 dx. Now, yesterday it was suggested that, hey, why don't we just solve for dx and then go from there? Here's where you might want to be careful with that. When you have this sort of thing, it starts to get a little bit complicated. Not that you can't do it that way. You can go, 1 over 2x plus 2. But bringing it back over here, I think, personally, I'd rather do it this way. So watch what I'm suggesting. Now, do we have this over here? Pretty close. What you should recognize is this. Bracket dx. So we would have 2 times x plus 1. And we do have x plus 1 over here. See that? So I go over here and I say, hey, what if I inserted a 2 into this integral and a 1/2 out here? That's what we did yesterday. And we tried to isolate, what du equals. See that? And that matches. And so now we can do our U substitution, and we have, this will be U, and this will be du. Okay, so I'll just write that, and we're going to have 1/2. I'm just going to write it with a U here, 1 over U, du. So again, here's U, and here is du. And I just substitute that in and come up with this integral. Now, any issues with this? Any questions you have about that? Is that troublesome for anyone? Is there anything you want me to go over again? Yeah. Okay, so the question being, how do I know this is you? Right? Well, in this question, they give it to you. You're given that this is what you want to work with. But let's say you're not given this, right? And you're asking, okay, well, what's u? Is it x squared? Is it 2x? Is it x plus 1? Remember what you're looking for. You're looking for a function, right? So you don't want to pick out x squared, probably. You want to maybe look at this as a whole or this as a whole. Second thing you're looking for is, do I find the derivative somewhere in the integral? And in this case, if you look at this as being u, and you say, okay, what's the integral? 2x plus 2. Oh, my goodness. You have x plus 1, which, if you multiply that by 2, you would have the derivative. So you're looking for u and its derivative somewhere in there. So if you can find that pairing, that's your indication, hey, I know what u has to be. But in this example, they tell us what u is going to be. But that's a very good question. And it just comes with practice, just like a lot of other stuff in calculus. It's just practice. Testing things out. Let's say you pick this for u. You might find that you're going to be in a lot of trouble over here. So then you say, well, maybe I should substitute something else in for u, and that sort of thing. Okay? So if we just continue this then, 1 over u, remember this and this can go away because this is u, it's just like this is. And so we have 1/2 the natural logarithm of the absolute value of u. Okay, is the antiderivative of 1 over u, right? And then we substitute back in, and so our answer over here in pink is 1/2 the natural logarithm of the absolute value of x squared plus 2x minus 6 plus c. Okay, check out there. And of course, you know, we could take the derivative of this and to check to see if we get this back, right? And if you want to do that just even mentally here, the derivative of ln of u, or ln of this, would be 1 over this times the derivative of this inside, which is 2x plus 2. If you divide 2 off of that, 2x plus 2, you get x plus 1. And so you get 1 over this times x plus 1, which is the same as what we began with. Okay? Example. Example 1. Okay, so the second example I want to do here for you is this one right here. If we took the integral of x times x squared plus 4 to the power of 8 dx, and you look at this and you say, well, oh boy, I've got a binomial to the power of 8, so it's going to be a little bit of work for me to expand that. I don't want to do that. And also I've got x times this. Now it appears that we have two functions here, right? It appears that I have function times another function, excuse me, which really I do. And you may be thinking, okay, I can't do U substitution here, but actually, if you consider again what U is and what du is, you see that we're not far off here, right? So let's take a look. Excuse me. If this was a U, let's just say, x squared plus 4, then du would be 2x dx. And you see that, okay, so this is your u, right? And 2x dx, I almost have that. I have x dx. I have 1x dx. And so this could be part of the differential, all right? So you don't have to think, oh my goodness, how do I undo product rule? You don't have to think that way because it just so happens that x dx is part of the differential. And of course, to get 2x dx, right, put a 2 there, put a 1/2 outside. And if I take the time to rewrite that now I have x squared plus 4 to the power of 8, 2x dx. So again, this transition from here through here to here is huge. That's the biggest, that's 95% of what we're doing. And so I just want you to absorb this. I just want you to kind of see where it's coming from. As a matter of fact, I'll probably, let me just erase everything. Let me do it again. Okay? Let me just do it again. Gone. Okay? Where have you gone, bracket? There you are. Okay? So you're looking at this and you're saying, I have to pick a U. Okay? One lonely lamb. Get the joke there. A U, sheep, lamb, E-W-E. No, okay. Forget it. It's all right. I have to pick a U, and you're wondering, well, I should probably stick with an entire inner function. So you're looking at this right here, and you're thinking, maybe that's U. It's not me. Could be you. And then you say, okay, well, if that's U, what's du? Du is 2x. And do I have 2x dx anywhere? And you say, hey, I almost have 2x dx. I have x dx. And so then you say, yes, this can be u. So u is x squared plus 4. And because the du can easily be shown here. Okay, so again, you get this. You get 1/2 x squared plus 4 all to the power of 8 times 2x dx. So then you go ahead and substitute. Yeah, question? Okay, so the question is, why do I have to get rid of this? Why can't you just leave that? Because this next step is going to be this. Right? This is going to be u to the power of 8.
That's not what I was asking. I mean, 2x dx is
2x dx is the u, correct.
Yeah. What gives us the ability to put that in for dx?
Okay, why can you substitute this for, why can you put du instead of this? Like, are you saying, why do I make this?
Substituting du for dx.
2x dx is du. And so if I have 2x dx here, that's
Why
du.
are we swapping it in for
So we go back to yesterday. I think we had this question yesterday. It's like, well, how does this dx become 2x dx? This x over here, I just moved it around. I moved it over here, and so it's right here. It's not there, it's over here. And so that's close to what du equals, and I just needed to get a 2 in this unit, and that's where the 2 and the 1/2 came from. Okay, so that's your question, where did this part come from, really? Where did the x come from? Yeah. Yeah, you can move that around from over here. So if it's x times this whole thing times dx, you can think of that as a multiplication. Just like we're thinking of du dx as a division, even though it's not really a division, but we can treat it like a division. So if we had this, you could actually write this as a differential, and it would be like this. Okay? So then from here, then 1/2, we actually have, so what's the antiderivative of u to the 8? That's 1 over 9, u to the 9. And of course this and this get dropped off when we do that, plus c. And x squared plus 4 gets substituted in here, and we can simplify this. So that becomes 1 over 18 x squared plus 4 to the power of 9 plus c. And that is our indefinite integral right here.